Okay, the next problem is another titration curve problem that deals with the same basic type of experiments. In the previous problem, you were given Ka of the acid you're titrating and all of the titration data and asked to calculate the pH of the equivalence points. Here, it's kind of the reverse. You are given the pH of the equivalence point and you are asked to calculate Ka or Kb. Okay? But again, the process is similar to the previous one, in that you are simply figuring out what the equilibrium concentration is at the equivalence point. So, pyridine is a weak organic base. When a 50 milliliter sample of 0.250 molar pyridine is titrated with 0.185 molar hydrochloric acid, the pH is found to be 3.10. Calculate Kb for pyridine. What's a good place to start?
Write our equation.
I'm just going to call pyridine B. So our equation is B plus H plus reacts to form BH plus. The reason the pH is significantly less than 7 is because you are forming a solution of a weak acid, BH plus, at the equivalence points. Okay? So in order to calculate Kb for pyridine, well, at the equivalence point, do we really have a substantial concentration of pyridine? No.
Ideally, you have 0.
Well, not 0, but it's pretty small.
Well, right.
0 governed by the whatever Kb is.
Yeah.
Well, more
Ka.
directly governed by Ka for the pyridinium cation, which is the conjugate acid. So we're going to get Kb for pyridine simply by first finding Ka for the conjugate acid and then using Kw to convert. Okay? So here's the equation for the titration. That's the reaction that takes place. At the equivalence point, what's the major equilibrium that's taking place that's giving us a pH of 3.10?
BH is ionizing to form hydrogen cations and H minus.
Just B.
Blonde.
Yeah.
Sorry.
Okay. So this is the equilibrium that's being established at the equivalence point. And so the question is, can we use information that we're given to calculate Ka for pyridine? We probably can. Okay. So we know that Ka for the pyridinium cation. So this is going to be equal to H plus B over BH plus. Do we know the hydrogen ion concentration at the equivalence point?
But yeah, we do. It's pH.
Yeah, but pH allows us to calculate that, okay? By stoichiometry, what's the relationship between the hydrogen ion concentration and the concentration of pyridine?
Equivalent.
They're equal to each other. So in order to solve for Ka, we really need to figure out what the concentration of the pyridinium cation, BH plus, is at the equivalence points. And we're going to do that with our titration data, okay? So the concentration of the conjugate acid is simply going to be moles of BH plus over total volume. Okay. So again, the total volume is going to include the volume of the base we started with plus the volume of acid we needed in order to completely titrate it. So let's go ahead and calculate that quantity. So we are starting with 0.250 molar base times 0.0500 liters is equal to, I'm too lazy to do that in my head, which is really sad.
No.
0.0125 moles of base, which means we also need 0.0125 moles of HCl required, and it also means we're going to get 0.0125 moles of BH plus. Okay, so I'll go ahead and 0.0125 moles. So the volume of HCl is going to be moles over molarity equals 0.0125 moles of HCl required, divided by the molarity of hydrochloric acid, which is
0.185, and I believe your answer is 0.0676.
0.0676 liters of HCl. So now I can say that my total volume is the 50 milliliters I started with, 0.0500 liters of pyridine solution I began with, plus the 0.0676 liters of acid solution required to titrate it, which gives me a concentration of 0.106 molar BH plus. That then goes back into the Ka expression. I'll do the annoying thin red line again. And let's bring that all down here. And I will now say Ka equals, well, the hydrogen ion concentration is going to be 10 to the negative 3.10.
So let's just put that.
Are you finished?
We'll square the
yeah.
whole thing over the concentration of BH plus, which is 0.106. That gives me a Ka value of
5.93 times 10 to the negative 6.
not that I don't believe you.
Eh,
5.9 times 10 to the negative 6.
redundancy is good now and then. Although the work I put on the piece of paper certainly doesn't show that.
So Kb is Kw over 5.9 times 10 to the negative 6, or (1.7 times 10 to the negative 9)
Agreed.
equals.
Check.
Go away. Kb.
Next one's Henderson Hasselbalch.
Yes.
Can I get a huzzah?
Huzzah!
Hi, Zacharias.
Shh. Bye.
You still didn't stop it.
Stop.
I think you're still on 10.
Oh.
That's what's